NTU World of Wisdom. Welcome to High Impact Thesis. In this podcast, we speak with researchers from various scientific fields to talk about the motivation, goal, and potential impact of their research. We also want to give you a sense of how a Ph.D. is carried out with an emphasis on the PH, the philosophical aspects involved in pursuing a Ph.D. Hello, everybody. So welcome to the High Impact Thesis podcast. Today's guest is Elinor Meredith. Elinor, it is quite a pleasure to have you at the High Impact Thesis podcast.
Thank you.
So, Elinor, we would like to really just find out from you the shortest possible summary of what you do that you can share with us at the beginning of our conversation.
Sure, yeah. Thank you for having me on this podcast. So I'm a PhD student. I'm in the Volcanic Hazards and Risk Group at the Earth Observatory of Singapore under Susanna Jenkins. So we're studying the hazards and the impacts that come from volcanic eruptions and assess the risk that's faced by communities that live in these volcanically active areas. So we want to try to understand, like, for a particular volcano, we want to look at what are the types of hazards that come from an eruption, what can you expect from an eruption, and then look at the impacts. So what are the types of damage you get to buildings and infrastructure, and what can we expect? So basically, it's collecting data from past eruptions, so looking at the hazards and impacts in the past, finding any relationships between them, and then using it to build models and forecast what we can expect in the future.
Okay, I think that's a good intro, and I think you've touched on this a bit, but the goal is to predict volcanoes, or the goal is to understand the physics of volcanoes at a high level. What is sort of the goal of this kind of research?
So there's lots of volcanologists that will look at, like, monitoring data and maybe the petrology or the rocks that come from volcanoes. But our specific group or our research field is looking at after the eruption has occurred. So what kind of hazards can you expect? So we've all seen eruptions around the world where you've got the huge plumes of ash or the lava flows or like the big flows of ash, which are called pyroclastic flows. So once the eruption has already occurred, what are the types of impacts we can predict or forecast for a certain region? So that's kind of what we're looking at. So instead of trying to predict when, which is very difficult, we're more looking at if. So if it occurs, what can we expect, and how can we mitigate or prevent future impacts from these eruptions?
And for you as a person, what was the motivation for you? Did you encounter volcanoes, or was it just a childhood interest? Because I really haven't met someone studying volcanoes.
Yeah, it's quite a niche topic, especially in Singapore. And I'm also from England, where we don't have any volcanoes. So I think for me, it's always just been really interesting to look at or to research about disasters or very rare events that happen around the world, or very disastrous events, because they're not very common in England or in Singapore. And my background is actually in geography. So I've kind of come from more of a social side of looking at how we as humans interact with the environment. And in England, the main risk that we look at is flood risk, because that's kind of the only hazard that we have. So I kind of went into flooding, and I was so interested in modeling floods that it kind of grew from there, that I then went into more like risk from all of disasters in my master's. And then I found my supervisor now, who's just looking at volcanoes. So I kind of just went in. So I kind of come from a broader background of geography, and then I funneled down just to look at volcanic risk.
All right.
Yeah.
That's enough background for us to get more into detail about your work, which Ahmed will now take over.
Okay.
Or if Ahmed, you have any questions, more general questions, welcome to ask, of course.
Sure. I mean, we can get into those as well. In addition to also exploring what you do actually in your PhD and what are the tools you're using and what are the questions you're asking in order to carry on your research. So let me start by this. For example, we talked about different data that you collect to assess the risks, right? So can you tell us more about these data?
Yeah. So when you're looking at the impacts from an eruption, the main ways that we can collect data is either by satellite imagery. So you've got like photographs of before and after an eruption, and you can compare the images, or you can go to the field yourself. So once an eruption has occurred, you can conduct a post-eruption field assessment or an impact assessment, where you go to each of the buildings and you decide on the severity of damage to each structure. Or you can look at historical reports. So you can kind of look at news reports or eyewitness accounts to see about the types of damage and impacts we've had from eruptions. But
So
also
does your work... Yeah, please carry on.
Yeah, so my PhD is specifically about lava flows, and that's because there's not a lot of data on lava flows, and that's lava flow impacts in particular, because typically lava flows haven't killed as many people as other hazards, and that's because we can generally evacuate quickly away from lava flows. They're quite slow in comparison to like pyroclastic flows. And also they rarely impact communities. So for my PhD, it's very difficult to gather much data because we haven't had many lava flows that have impacted communities, and those that have happened have been quite far in the past, so we don't have satellite imagery. There's also problems with like accessing property, like people's homes and properties, or even accessing the country to gather data. So I think for me, my PhD is based on can we use the very few data points that we have from impacts from lava flows to try and build these models that we have done for other hazards.
So when lava flows and volcanoes, they're closely connected. Is that right? When you were talking about lava flows, it's when a volcano happens, then there's lava flow. Am I right?
Yeah, so there's different kinds of volcanoes, and they can each have different types of lava flows. But most commonly, lava flows will come from these shield volcanoes. So these are very, very flat volcanoes. And if you've seen volcanoes in Hawaii, for example, they're very flat. They look like shields. And the lava flows here will be very fast, very hot. And that's typically where you get lava flows. But you can also get them at the more the like stratovolcanoes, so the taller ones that you typically see around the world. But these lava flows are a different. They typically are a different style. So for my PhD, the majority of data is going to be from Hawaii, because that's where communities have been affected the most.
Right. I did want to ask you about what areas are you covering, and has your research taken you anywhere yet? Like, have you been on the ground basically on these sites?
Yeah. So in my first year, I got the opportunity to go to Hawaii. So they have a few volcanoes there, but they had a recent eruption in 2018 where lava flows erupted under a community. So from in the middle of a community, large cracks or fissures just opened up under houses, and then lava flows erupted. And this happened for several months and destroyed over 30 square kilometers of land. So I got to go there and assess the buildings and the impacts from this eruption. So I did this field assessment that was there. And now, because we can't really travel anywhere else at the moment, I'm just gathering any other data that we have around the world. So there's been very few other lava flow examples that have hit communities. And we're trying to gather some data from those. But what we're ultimately doing is collecting data from eruptions from around the world at these like data-rich areas where we can get the most data, and then apply them to data-poor areas. So volcanoes, for example, in Southeast Asia, and particularly in Indonesia, where we don't have a lot of understanding of risks or volcanic risks, we can start to apply or start to understand better risks in these areas. So that's the ultimate goal.
When you say that a lava flow just happened in the community, I'm a little unclear. Can it happen just like that? I thought there are like places that are, I don't know, mountains. I guess that's what we learned in our geography classes, where specific locations where volcanoes or lava flows are expected to happen. So I'm wondering, in Hawaii, was it a place that scientists sort of have an expectation of such a thing happening, or is it really out of the blue then there was a lava flow for the case?
I think in Hawaii they have general they accept that there's high risk there. So the general structure of the volcano is called Kilauea, and it's got the crater in the sort of southern center of the island. And then stretching from the east and the west, we've got these huge rift zones. So there's these cracks under the ground. And then along these rift zones, people still live. So you can have like farming there and agriculture, and also communities living. So they're away from that central crater where you can have the explosive, like the ash plumes and other hazards. But the lava can still sort of travel down the cracks along the rift zones. And then if they reach the surface, they can impact communities, which is what happened. And it's been, these lava flows have happened a lot in Hawaii over the past century. And I think people have begun to accept the risk of living in such a risky area.
Yeah. Okay. So I wanted to touch on something you mentioned earlier, where you said you take examples from rich data areas and then apply them to poor data areas. So can you give us like an example on how would that work?
Yeah, so I haven't got really to that part with lava flows yet in my research. So at the moment, I've only collected lots of data and starting to analyze it before putting it into models. But it's been done for other hazards like ashfall, for example. So when you have huge plumes of ash into the air from a volcano, and then the wind is going to make the ash travel in a certain direction, and then it's going to fall, and typically it's going to fall on agriculture or buildings and communities that live around the volcano. And then so in your field assessment, you can assess, you can take note of the thickness. So how thick is the ash in that particular community? And then what are the types of damage you get with that thickness? So then you're looking at the relationship between thickness of the ash and the damage. So at what thicknesses are you going to collapse a roof, for example? Or are you going to cause holes in the roof, or cause some damage or destruction? So you're relating the thickness with damage. And then that you can then build models where you look at the probabilities, collating all this data together, where you can look at the probability of each type of damage, so each severity. So then that's how you can then apply it to other volcanoes. So if we say at a eruption at a volcano in Indonesia, for example, if we've looked at if we've looked at past eruptions from this volcano, and we know that typically it's going to be this size of eruption, if the wind is going in this direction, the ash will fall on this community, and then we can expect a certain thickness. And then that's how we can predict, well, as they have this type of roof, or because it's this structure, we can work out how much damage or how much destruction at that community. So basically you're using an example from another type of another volcano, but a similar type of hazard, and applying it to other volcanoes. Yeah. Okay,
so 2 words there: damage and destruction. And yes. I think from like quickly reading up on your papers, you have some sort of clarification about the difference and the general conception about the 2 effects of volcanoes, right?
Yeah, I think that's the point, right? Because when people think of eruptions, you just think of destruction, particularly with lava flows. They're so hot and fast flowing, and you think of if that gets in contact with someone's house, it's just going to destroy it. But more recently, in the past few decades, there's been more studies that look at the variety of the damage. So it's not just binary, it's not just it stays intact because it's not in contact with the lava flow, or if it's in contact, then it's destroyed. Actually, there's a lot more complexity to that, with lots of hazards, but also we're noticing now with lava flows, because in the past, news reports are going to be using words like this community was wiped out or destroyed or threatened. We know of lots of lava flows in Hawaii or Italy and in Japan where lava flows have destroyed whole communities. But more recently, the studies or damage reports are a lot more quantitative. So they're counting the number of buildings that have been destroyed or geolocating where the buildings are that have been impacted. Most recently, there was a lava flow at Nyiragongo volcano, which is in Africa, in May this year. So we can already get satellite imagery and then count the number of structures that have been destroyed or impacted by the lava flow. But actually, in my PhD, we're looking at it's actually useful to gather even more information. So not just whether it was destroyed or just the number of destroyed, but we want to look at the types of damage or recording like specifics instead, right? So how thick was that lava flow? What were the mechanisms of damage? So was it that there's melting of plastic, or was there like complete inundation, or was the building surrounded by the lava flow? So is the lava flow affected, or is the damage affected by the shape or the material of the building? Or is it affected by the characteristics? So how thick is the lava flow? So once we start to identify these things, we can then pick out like what's the most vulnerable, what's the least vulnerable structures, and then how best can we mitigate against these in the future? So what are the types of, like if we really want to protect one particular infrastructure, what are the best materials or what shape of building can we use to reduce impacts in the future?
Yeah, I'd really would like to get to that, but before we move on, speaking of eruptions, right? Can we really tell how far will the lava reach, like from the eruption, depending on the shape of the volcano, or is there any indication on the extent of the damage?
So I think that lava flows are particularly difficult to model, and that's because the rheology, so the insides of the lava flow, are very difficult to model. But at the moment, when there is the signs or the start of an eruption, we can create like these footprints, so these hazard maps of a lava flow. And the way that those are made is by looking at the topography, so looking at the land, because we know that lava flows, they're going to travel down the direction of the lowest topography. So if we have a fissure, so a crack in the ground, and the lava is erupting, then we can then model where the lava is going to go based on the topography. But the main issue is we don't know how much lava is going to be erupted. So in that case, it's very difficult to predict like how far the lava is going to travel. But in like at the time of the eruption, typically you just want everyone in that community to evacuate because you don't know how far it's going to go.
Right, you assume the worst, I guess.
Yeah.
So for satellites, is it mostly looking at optical images, or are there other frequency bands that you look at when analyzing volcanoes or lava flows?
So whatever's available, really. And it's difficult because there's lots of clouds, or there's only specific, might not be high resolution.
Right.
So, yeah. So whatever is available. And what is being used more in disasters and eruptions is the use of drones. So we're capturing more and more photos by using drone imagery. So whatever is like highest resolution and the quickest data. So as soon as the eruption happens, we need to capture as much data as possible and as much imagery as we can. So whatever sources of data that comes with is good.
Okay, so you have all these data from different sources, right? Like satellites, drones, and field analysis. What do you do with these data? So here in the podcast, also, we usually try to find out what kind of tools the researchers here in NTU are using, what kind of software, what kind of devices. So can you tell us a little bit about that?
Yeah, but it's quite straightforward. So we just gather. For me, for my PhD, I just had thousands of photographs that were taken by our collaborators in Hawaii. And also I went there myself and took photographs. So I was actually manually going through all of the photos and assigning them to buildings and assessing the damage. So that took quite a long time. But also obviously those are geolocated. So we just upload those into GIS software. And then we're just mapping the lava flow and mapping the using like OpenStreetMap data. So that's which shape files of all the buildings. And then we're just creating like geolocated map of all of the damage and the destruction. Yeah. And then building the models, we're using like Excel and coding to then create these models of probabilities of damage.
Is this an approach that your group is following, or is this is a general approach in the field?
So actually it's quite a new field. So only very few people around the world are looking at volcanic impacts, but it's been well studied for other hazards. So for example, earthquakes. We know that there's lots of buildings now or building regulations that protect structures against earthquakes, or building resistant structures to earthquakes. And that's because they've got a lot of data. So they were able to build these models and we can then protect our structures. But for volcanoes, it's quite a new field. So it's only in the last 20 years that we've really got enough data. So actually, you could see that in other fields, they're using maybe more advanced technology, or they're using AI and satellite imagery. But because we're so new, we need to capture as much information and data as possible. So I could just compare before and after images of using satellite images and see whether a structure is damaged or destroyed, or it's intact. But actually, we don't capture enough information. So when you go out there in the field yourself, you can see the 3D house, And then you can see all of the more minor damage that you're not going to collect from satellite imagery. So there are other research groups that are using like AI to compare satellite images like before and after eruptions or before and after earthquakes. But because we're quite new in our field, we're trying to capture as much information as possible because it's quite rare that lava flows are going to affect communities. So we need to capture and get as much information about the minor types of damage and as much data as possible whenever there's an eruption.
So coming back to mitigation, right, and protecting the communities. So we can also talk about how people, like you said, need to be there. I even just remember an example in Indonesia. I think people also find work opportunities because there's certain material that is only available around volcanoes and active ones at that. So maybe does your work involve suggesting ways to protect the communities, or do you just provide your results and conclusion to other groups that or maybe policymakers to take care of that?
Yeah. So it's definitely important to involve as many local people and communities and local policymakers so that it actually has an impact to people. So for me in Hawaii, I'm publishing papers on this, but it hopefully will reach the people who actually are impacted by the eruption. And so it will go to our local collaborators and local communities there. But in terms of mitigation measures, we don't really tell people what to do because it depends on many reasons why they can and can't change their home. But we kind of provide, in our papers, we're providing more like guidelines or findings. So we could say these types of structures are more resistant to a certain hazard, so we have suggestions or guidelines for the types of structures that are more and less resilient, but we don't instruct people how to change structures. Yeah.
I'd imagine also based on the geography of the area, there would be certain locations around the volcano where it's safer than others. Oh, and people might not know about that, for example.
Yeah, I think so. And that's why it's really important to be very clear with hazard maps. So we produce more maps about the impacts, but we can also create these hazard maps. So this is likely regions of where hazards may extend to or may impact or may erupt from. And so it's very important that local people can see these maps and that we communicate clearly with local people so that they are aware of the risks and where they're living. A lot of the time people feel quite safe because they're relying on the local government or local community leaders to tell them when to evacuate. And there's many other factors, like people might not want to evacuate because they feel sense of connection to their land or their home. So there's many reasons about evacuating or where is safe. But as scientists, we definitely have a role or a duty to provide the science or maps of where is highest and lowest risk.
Yeah, I guess you also have to be quite balanced as scientists. I was just reading, I think it was yesterday or today morning, about some scientists in Italy who were almost jailed because apparently they weren't able to predict an earthquake. Or they offered advice that downplayed the risk of the earthquake. So I guess, yes, you do the science, and then on the policy side, you have to tread quite carefully because obviously you're dealing with people who are not necessarily scientists, perhaps, and they see the world in a different way. So I think I can understand why you might not say move to that place because who knows, right? Okay.
Yeah.
Right. Okay. So actually, it's interesting to hear that this whole field is quite new. Like yeah, maybe 20 plus or minus. So yeah, it was interesting to know that there's still a lot of way to go. So maybe if you can tell us, like from your own perspective, where do you see kind of, or how do you see this research developing in the future, and what kind of impact do you think it will, have on a global scale?
Yeah, so as it's quite new, looking at impacts from volcanoes, what we're doing is providing like a standardized method that can go forward. So we have these databases of impacts that have been recorded and the hazards that have caused those impacts. So having these databases means that going forward, we can just compile more and more data, and that means that our models and our forecasts will become more and more robust and reliable. So we're basically just at the start, really, just with the potential of what we can do. But I guess it really depends on the amount of eruption. So whenever we have an eruption where we can gather data is very useful for us, because we can assess risk in these regions and collect as much data as possible. So the more eruptions that occur, like through time, it's going to be added to our databases. Yeah.
I'd like to ask a few rather general questions, really, about volcanoes.
Yes.
You don't have to be an expert in this, but I want to hear your thoughts. When volcanoes erupt, do they ever produce minerals that are of interest, that are special minerals that can be, I can start a business in? Or is it just stuff that burns people's homes?
Well, it depends where you are, right? Because if you're in a volcanic region, then those rocks are quite common, or those minerals are quite common, and part of, like, when you have an eruption, the ashfall and the lava becomes like on the ground and becomes part of your environment. So in those regions, it's quite common. But I guess the further away you go, they're less common. But what's interesting, for example, in Hawaii, is it's quite superstitious that you shouldn't take any of the lava or take rocks away from the islands. And people have had, I think if they take the lava rocks from the islands, then they have like bad experiences, or if something bad happens, they think it's because they've taken the lava. So then they take it back. They have to go back and return the lava to the islands.
And then they.
So yeah, I think you shouldn't.
Okay, it might not be a good business.
Yeah.
And do you look at volcano? I realize you talked about Hawaiian places here on planet Earth, but do you look at other planets, or do you do any comparisons with volcanoes on other planets, whether you or your lab?
I think there are scientists that do, but for us, we don't, because we're just looking at communities and impacts to people and buildings. So at the moment, we haven't ventured out from Earth.
Okay. Okay, yeah. Cool.
Right.
And I guess the last one is, if you personally, what are some of the, I guess, most shocking things you found about volcanoes, about this field in general? You say you only joined, you were in a more general geography field. Now you're more into volcanoes. I'm wondering whether there's some that shocked you when you thought like, oh wow, I didn't know that.
Well, I think what I've realized is that from someone that's from England, where we don't have volcanoes, and I've been to only a few volcanoes around the world, but people are okay with living with risks, and they kind of, for themselves, weigh up whether they want to live there, and they're okay with the risks that come with living near a volcano. So I think that's quite shocking to me, because I think growing up, you always think that volcanoes are very scary, dangerous environments, but actually people living there are okay with these risks. And another thing is, I think we have to be very careful as scientists to be very sensitive with the people that are living there. So, for example, we can't like publish photographs of people's homes or homes being destroyed or things like that, because these are people's whole lives and livelihoods that are being destroyed, and we can't kind of use that to gain published papers or for our own scientific gain, especially for NTU, where we don't have any volcanoes near us. We'll have to go abroad. So I think we have to be very sensitive, try and collaborate with as many locals as we possibly can, and make sure that people are aware of what we're doing, and just being careful and sensitive when we're publishing these kind of data, and make people aware that it's the overall aim is to forecast future impacts and try and reduce the risks in the future for these people living at volcanoes.
All right. Thank you.
I gotta ask you this. Have you ever gone or considered going volcano bungee jumping?
No.
Have you heard of such a thing?
I've been up volcanoes. I've been to up volcanoes, but I haven't been bungee jumping. No, especially not in a volcano.
That's interesting, because in fact,
scary.
one of the questions I wrote down just now is a question about whether volcanoes can be something to do with tourism. Like, do they have something that could be sort of entertainment aspect to it or fun aspect to it? Because obviously we think of them as these natural disasters that aren't good for humanity. But I'm just wondering if there is actually an angle, like Ahmed is trying to point out, maybe an angle where it's a fun thing that we might in some way want to have. Is there anything like that?
It's interesting because in Hawaii and at other places around the world, when you have an eruption, you think that tourism is going to go down, but it in fact either stabilizes or increases because people want to travel there to go and see the lava. So I think lava in itself is like attracts the tourists.
I see.
Yeah.
It's
and especially as volcanologists, like us volcanologists in my department, we will travel to go and see eruptions. But, yeah.
Right. So you don't look forward to, you don't want them to happen, but you also would like to have them happen.
Yeah.
Because those are data points for you.
Yeah, that's the thing.
It's actually quite interesting because I think that there's also a group of researchers that work on predicting when certain volcanoes will erupt, right? And certain people look at this data to protect themselves and get away from the area, while others look at the data to plan their trip to that place and witness the eruption. Yeah.
Yeah, which is particularly dangerous. But yeah, I think people do that.
Okay. All right. So we've learned quite a bit about volcanoes and maybe your love for volcanoes as well. But we're just wondering what other aspects of your life could you share with us? So these are things external to your research. Yeah.
Yeah.
And I think fun and interesting, worth sharing.
Well, I guess usually I would say that I travel a lot, and that's one of my hobbies, would be traveling. But it's been quite difficult in the past 2 years, not traveling and haven't been home. So I'm trying to make the most of living and being stuck in Singapore and exploring. But yeah, apart from that, I'm quite active in GSA as the welfare director. So I'm quite passionate about supporting students with their mental health in academia. So I'm leading a team, like a welfare team with 20 other PhD students, and we're running different initiatives and workshops to support students' mental well-being. So like I'm leading the annual NTU Mental Health Week, and I'm often communicating and in meetings with senior management to raise different graduate issues. So I'm quite busy outside of when I don't want to think about lava flows, then I've got lots of other things to do.
All right. And the GSA is, because this is actually quite an international podcast, maybe just
Right.
1, 2, or 3 lines about what the GSA is.
So yeah, it's the Graduate Student Association. So it's just a group of postgrads who put on different events and listen to the graduate community at NTU and try to address different issues and run different events to support students.
All right.
Yes, in fact, this podcast is an initiative of NTU World of Wisdom, which is part of the Graduate Student Association. So it all links together.
Yeah, links.
Yeah.
So thanks a lot, Elinor. It's been a nice conversation. You've talked to us about what volcanoes are, about the places you have visited to collect data, real data on the ground, so that your models obviously are backed by reality. And I think I have learned quite a bit. I realized that maybe the minerals they are not worth going to get because I might have bad luck. But overall, I really enjoyed the conversation. Is there anything that you would like to share in general that we might not have touched on? You really are welcome to just say, okay, by the way, this thing or that thing.
Trying to think.
Or maybe something you would, I don't know, encourage someone to, I guess, if someone were to come into your field, what would they look forward to? It's just a general thing, so you don't really have to say something. Okay, it's just that we would like to give our guests the time for them to say whatever, in case we missed something or something that you would like to clarify or anything like that.
Yeah, in fact, if you have nothing, that means we did a good job.
I guess like one interesting thing is, we're in Singapore and we don't have volcanoes. And so you might think, why do we have Earth Observatory of Singapore where a large proportion of the faculty is studying volcanoes?
You're right.
And actually, there can be eruptions that happen near Singapore, so in Indonesia or in the Philippines, where the ash could actually travel and affect Singapore.
Mm-hmm.
So there has been an eruption in 1991 of Pinatubo in Philippines, and that ash traveled across the sea and landed in Singapore, and it affected locals. So, not only are we doing research where we're looking into risks in Southeast Asia, but some of these risks are also in Singapore as well.
Mm-hmm.
Yeah.
So
which I think is quite interesting, because I didn't know that we could be impacted by different hazards here in Singapore.
Very nice.
We think we're fairly safe.
So I guess no one is ever too safe. I mean, we are definitely connected, right? Even if it's not just physically, the ash would be here, but it's when something happens in any part of the world these days, to some degree, we're also affected. So even if Singapore doesn't get let's say volcanoes, but I do feel that having EOS obviously helps Singapore and the world at large. Okay, that will be it for today, and thank you for your time.
Yeah, thank you for having me.
All right.
Thank you.
All right, thank you very much.
Thank you.
Bye-bye.